Hello, this is Bradley Needham. I'm going to be talking about runtime type information, or RTTI, in C++. I will be using typeid and dynamic cast to identify the type of an object at runtime so that I can do some special processing on it. First, I'm going to create a simple inheritance hierarchy of polymorphic types. In this example, I'll use a shape class. Shape is going to provide a virtual method draw. And I may have a class rectangle that inherits from shape and overrides the draw method and provides an implementation. I may also have another class, ellipse, which also inherits from shape and also overrides the draw method and provides an implementation. Now I'm going to create a couple of helper functions basically to generate random shapes for me, but you can think about this as a function where you're getting this collection of random shapes from a framework or from another part of the program that you don't have control over. Okay, so this function simply returns either a rectangle or an ellipse, and then I might have another function that returns a collection of random shapes given the number of random shapes you want generated. So now in my main, I can create a collection of random shapes, let's say 7. And just for this example, since I know I'm actually creating these, I'm going to go ahead and clean them up. So what can I do with this set of shapes? Well, let's say I need to get all of the rectangles. Maybe the user has selected all rectangles or wants to select all rectangles, and so I need some way of identifying the rectangles in this shape array that I've gotten back from a framework somewhere. One way to solve this problem is with RTTI, and that's what we're going to go ahead and do. So we're going to create a function called getRectangles, and it's going to take in as its parameter the collection of all of the shapes. And what it should return to me is going to be a new collection of rectangle pointers. So let's go ahead and write this function. Now, the first time we write this function, we're going to write it using typeid. Return type is a vector of rectangles, get rectangles, and it's going to take a const reference to a vector of shapes. I want to create my return value. And now what I want to do is loop over all of the shapes and identify which ones are rectangles, and if I find a rectangle, put it into the collection of rectangles that I have. So what do I need to get? I need to find the type of the object that's being pointed to inside the shape vector. I can use typeid to return me a type info structure, and that type info structure I know has a name method on it, which basically provides a string representation of the type that I'm looking at. So let's print that out and see what it gives us. Right now we're just going to return the empty vector. So we have the call to get recs. Let's see what happens. Well, down here, you notice in my output is every line for every object is specified as p5 shape, and that's just the internal representation that my compiler is giving to this particular class type. Well, that particular class type happens to be shape. That's not what I want to see. I don't want to see the shape pointer. What I'm looking for is I want to know the type of the item that's actually being pointed to, and so I'm going to dereference the pointer that was passed in here. So let's go ahead and run this and look at here. Now we get the actual type of the object that is pointed to by the shape pointer, and you can see we have ellipses and we have rectangles. So what I need to do is find some way of identifying the rectangle. Now I don't want to go through and figure out what this internal representation is and then use that in my code, because this will be different for different compilers. So what I want to do is compare the type info structures. So I can do that by if typeid give me the type info structure for the class rectangle is equal to the type ID of the dereferenced shape pointer. And in that case, I will push that back into my vector. So I want to push the pointer back into my new vector, but of course the problem is that the type of all sub I is a shape pointer, and the type that I have inside the vector that I want to return is a rectangle vector. So what I need to do is actually cast this, and this is again where we can use static cast, because I know at this point that this pointer is a rectangle pointer. This is what the typeid has told me. And then let's go down here and loop over the collection of rectangles that we got. And we can just call draw on these so that we can see that they are rectangles. All right, so let's run it. And there we got it. We've created 7 random shapes, and output-wise looks like we've only gotten 4 of them actually being rectangles. We try running it again. We get 4 rectangles again. Again, seems like we're getting pretty close to 4 with our division. One way we can switch that is come up here into our random generator, change this to 3, and make case 1 and 2 report or create ellipses. We run it again, and now with 7 objects we're only getting 1 rectangle created. If we run it a few times, we still only get 1 rectangle created. We could create more random shapes, and perhaps we should get more rectangles. Yep, and now we have 4 rectangles. So this all works fine, right? We were able to identify the rectangle that we wanted. We created our new collection of rectangles and used them. But what happens if in that framework or that code that we don't have control over, somebody goes ahead and creates another specialization, square? And square inherits from rectangle, still overrides the draw method, and provides his own implementation. And we have to go down here and make sure that we create a square in our random generation here. So we'll bump this up to 3, and we'll bump this up to 4, and we'll create a new square. Well, even though it's pretty likely that a square will be generated, let's go ahead and run it. We notice we're still only getting rectangles in our rectangle collection. This is because this test here is testing only specifically for the class rectangle, not for classes that inherit from rectangle. So it's not giving you everything that is a rectangle, it's giving you only things that are specifically the concrete class rectangle and none of its descendants. And that may be what you want, but in the case that that isn't what you want, what you might want to do instead of typeid is use dynamic cast. So let's go ahead and comment this part out, and we'll see how we might do this with dynamic cast. So dynamic cast means, so I'm going to want a rectangle pointer, and I'm going to take the shape pointer as being passed to me. I want to cast it, downcast it to a rectangle, and what I have to do is if r is not equal to the null pointer, that means that I actually have a rectangle. So dynamic cast will basically check to see not only is this the actual typeid of rectangle that is being pointed to by shape, but it will check also if there are any subclasses of rectangle that are involved. So I can then also push back that this is the rectangle that I want to put in here, and I don't have to ask for that again. I can simply say R because I've already done the casting, and this is of type rectangle star. So let's run this and see what happens. So now, just like we said, we were getting squares generated, we just weren't actually seeing them. And you can see now that there's a few rectangles and a few squares that are being generated, but still no ellipses are showing up because we are only grabbing things that inherit from rectangle. That's all I have. Hope that helps.